Matrix, I don't know if you remember this question, but I had shown you this question a little while ago, and I'd said to you, go away and go and try it and see if you could do it. So what I wanted to do was go through this with you today, because I wanted to do a lesson on functions, and I wanted to try and, as always, try and do some stuff with you that is a little bit more difficult, and that's what's nice about this particular question. All right, so let's jump in. It tells us that we have been given two graphs. First of all, we've been given the graph g of x, which is the graph 4x squared minus 6, and the other graph f of x is the graph of 2 root x. They've been sketched below. S is an x-intercept of g. K is a point between O and S. The straight line QKT with Q on graph F and T on graph G is drawn parallel to the y-axis. So it is a vertical line. Okay. So what they've given us here are, well, let me, before I say what it is, can you describe to me what sort of graph G is and what sort of graph F is? What is G? G is a? What sort of graph is G? Let's have a look. Correct, it's a parabola, 100%. Okay, what sort of graph is F? What sort of graph is F? Sorry, guys, I'm just getting my extra light here, my load shedding light. Okay, so inverse, but inverse of what, iPhone? Swanaka says it's exponential, and Balentle says it's an inverse graph, but what is it the inverse of? Is it a log graph? Is it the inverse of a straight line? What is it? What sort of inverse? Can anybody tell me? Okay, so Katleho says a log graph. Mbalentle says the inverse of a parabola. What do the rest of you think? Someone said the correct answer, but who is that person? iPhone says it's a log graph. Yes. Okay, so Chloe and Mbalentle, you are correct. It's the inverse of a parabola. How did you know that it was the inverse of a parabola? What was the clue that it was the inverse of a parabola? What made you think that? Or was it just a lucky guess? Okay, so the root sign did give it away. Good, Chloe. That's a good explanation. Yes, how would the root sign? Okay, so also, just to help, because before it was cut, it failed the vertical line test. Indeed, Mbalente. So before the domain was restricted, it would have failed the vertical line test and it would not have been a function. Okay, so iPhone, I'm sorry, I don't know your name, and Katleho, if it is a log graph, it will say there, this is the graph of f of x, or y equals log base whatever. All right, so it actually has to have the word log in it for it to be a logarithmic function. Also, log functions, like exponential functions, because they're the inverse of an exponential function, they have to have an asymptote. So it's not going to be touching the y-axis, because the y-axis would actually be the log graph's asymptote. Okay, so yes, the 2 root x was the clue that this had to be the inverse of a parabola. So it's a parabola and another inverse that they have given us. They've been sketched below. We've read all that information, etc., etc. Let's go and have a look at the question. So the first thing that they want us to do is determine the x coordinate of S correct to 2 decimal places. So what should I do? For 6.1, how am I going to work out the x-intercept at S? What should I do? Let y be equal to 0. Good. And you can see it's only out of 2 marks. So 1 mark will be for taking 4x squared minus 6 and making it equal to 0. Cool. So now we want to solve for x. What I'm going to do is I'm going to put the 4x squared on one side. I'm going to put the 6 on the other side. Divide both sides by 4. And that's going to leave me with 3 over 2. Right, and now I need to take the square root. Right, so remember when you take a square root, it could be plus minus, but because S is a point on the positive x-axis, it's only going to be the positive answer. Okay, so therefore x is going to be equal to positive whatever it is. So it's the square root of 3 over 2. What is that? What does that give us? I'm getting 1 comma 2, 2, and the rest of you should be getting that as well. Okay, so for 2 marks, 1 mark for making it equal to 0, and the other mark on the answer. Are we all good? Yes, all right. Zwanaka, you've got a hand up. What would you like to ask, Zwanaka?
Hello, ma'am.
Hello, Zwanaka.
Ma'am, would it be wrong if we leave it in the decimal form?
No, that's exactly what they wanted. Okay, because it does say here correct to 2 decimal places. I'm just highlighting that in yellow for you. All right, so that's what they wanted from us in this case, was in decimal form. Okay, let's carry on. The next thing that they want us to do is calculate the coordinates at the turning point of G. How are we going to calculate the coordinate? Sorry, Zwanaka.
I didn't see that, ma'am. Sorry, ma'am.
No, please don't apologize. Not a problem at all. It's difficult on screen. You know, we're going up, we're going down. Sometimes it's not easy. It's not on a piece of paper in front of you. Okay, so the coordinates at the turning point of G. Okay, because this is the graph 4x squared minus 6, it has not been shifted left or right. That means, that's it, iPhone, well done. We can just write down the answer like it says, write down. Okay, so the coordinates will be at 0 and minus 6. Okay, so everybody's happy with that. And it would be 1 mark on the X, another mark on the Y. All right, now getting into the more interesting questions. Question 6.3.1, first of all, they want us to write down the length of QKT in terms of X, where X is the X coordinate of K. So what can we say about the X coordinate of K and Q and T? What can we say about the X coordinate of K and Q and T? It's all the same, isn't it? Because they all lie in the same vertical line. Absolutely. All right. So how do we calculate the length of a vertical line in functions? What do they want us to do? How do we calculate the length of a vertical line? Can you guys remember? And it's not distance formula. How are we going to calculate the length of a vertical line? There we go, Nkonizer. Therefore, the length will be y of q minus y of t. Okay, so what you mean there is, I understand what you're saying. Okay, so it's the y at q minus the y at t. Good. All right, so the y at q minus the y at t. All right, so the y coordinate at q minus the y coordinate at t. That will give us the length of the vertical line. So how will we express the y at q? The y at q is? The y at q is? Q is a point on F. So the y at q is what f of x is equal to. So that's 2 root x. Does that make sense to everybody? So this is 2 root x. That is the y at q because q is a point on f and f of x is equal to 2 of x. Remember, f of x means y. Minus the y at t. T is a point on g. So g of x is 4x squared minus 6. All right, so when they want us to write it down in terms of x, we're going to have an x in our answer. So what we could do here is let's get rid of the root. So what exponent am I going to write the x with? Won't it be? Oh, yes, sorry. It's like that. I beg your pardon. Here I am being naughty. I left off my brackets. So it would be 2 root x minus 4x squared plus 6. Quite right. There we go. Good. Very naughty not to put brackets around my binomial. So what can I do with the root x? There we go, Iola. Lovely. All right, so I can write this as 2x to the power of a half minus 4x squared plus 6. Lovely. Okay, so here I think the marks would be obviously for the answer. Why is it out of 3? Write down the length. Knowing that you
I
needed
think the
to
formula
subtract.
also.
Yeah. All right. And now this is the reason why we are doing this question, everybody. So all of this, there we go, Nkonizer. All right. So Nkonizer's thinking long and hard. Very good, Nkonizer. So we want to calculate the maximum length of QT. So Nkonizer's suggestion, can we differentiate the next question to get the maximum length? Yes, we can. All right, so Nkonizer, let's make sure that we set it out correctly. How would we write the derivative of QKT? What notation could I use? How would I write this? I've got to use the correct notation as well. So it's not just what I'm doing, my maths, when I'm doing the differentiation. I've also got to make sure that my notation is correct. So what's the right way for me to set this out? That's the correct, no. Nkonizer, you close, but that's not 100% correct. So we want to set it out like this. We're going to take the derivative of QKT with respect to x. Okay, so set it out like that. And now we're going to do our power rule. So in Nkonizer, we've got to take, and everybody else, we've got to take that half and multiply it by 2, and we're going to get 1. And then we've got to take 1 away from our exponent. So that would give us x to the power of negative 1 over 2 minus 2 times 4 or -4 would give us -8, and then we've got to take 1 away. So I've found the derivative of QKT with respect to X. Does that make sense to everybody? Are we all good with that, everyone? Yes? Okay, and we've set it out nicely as well using the correct notation as well as getting the correct derivative. So for any minimum maximum problem, we know that to minimize, you keep forgetting to -1 from the exponent. Okay, so remember in Conizer, you're going to multiply your exponent with your coefficient. Okay, be careful of signs, and then you're going to take 1 away from your exponent. Okay, that is your rule for differentiation. So at any minimum or maximum, we know that the gradient is going to be equal to 0. Okay, so here what we would now need to do is make our derivative equal to 0. So we've got x to the -1/2 minus 8x. Now how am I going to manipulate this? What would you guys do? What would you guys do next? Any ideas on the mechanics of the maths at this point? What would we do here? So, okay, let me ask you one. Hang on, let's just wait and see what someone's saying here. Make the bases the same. Before we can do that in Conizer, before we can start solving for x, there's something that we've got to do first. First of all, do I want to work with a negative exponent? Do I want to work with a negative exponent? Can I get rid of the negative exponent and rather write it as a positive? Is it possible? Yes, absolutely. So I tell you what, I'm going to write this as 1 over x to the power of a positive half. Cool. And then the other thing that I could do in this case is I can take my -8x over to the other side and make it equal to positive 8x. What can I do now? I've taken the -8x over to the other side. I've written my what could I do now? I can cross multiply. Good, well done. So I'm going to cross multiply next. When I multiply like bases, what do I do with my exponents? Matrix, remember this is x to the power of 1. When I multiply like bases, I add my exponents. So 1 plus a half gives me 1.5 or 3/2. Now remember, I'm trying to solve for x. So I want to isolate my x. Good, Chad. Perfect. So I'm going to divide both sides by 8, and that's going to leave me with x to the power of 3/2 equals 1/8. Yes, Swanaka, what's the question?
Ma'am, I want to ask why
Yes.
exactly would we cross multiply?
Because you don't want the x in the denominator. Remember, you're trying to solve for x. So the best thing for you to do is to multiply both sides of the equation by x to the power of 1/2. Okay, so it ended up being in the denominator because we made the exponent positive. So we don't want to work with negative exponents when we're trying to solve for x. We want the exponent on our x to be a positive when we are solving.
So basically, this rule basically applies if we're going to find the maximum length.
Yes, because what we're going to do is we're trying to find the x coordinate at which the maximum occurs. And then once we know the x coordinate at which the maximum occurs, we can then take that x and go and sub it into our expression for QKT that we had from 6.3.1.
Okay, thank you, ma'am.
Okay, so that's what we're trying to do here. All right, so our next step matrix, we've got x to the power of, oopsie, that's almost illegible, x to the power of 3/2. And now what I'm going to do is I'm going to write 1/8 using base 2, 2 to the power of -3. And that's it, Chad, quite right. And then what I want to do here is I want to multiply this exponent by 2/3 so that I end up with x to the power of 1. And what I do to this exponent on this side, I've got to do the same thing on the other side over there. All right, so this is going to leave me with 2 to the power of -2, which means x would be equal to 1/4, which someone said, and that is quite right. That's it, Iola. Multiply both sides by the reciprocal of the exponent to get rid of the exponent. Beautifully put. I could not say it better. 100%. All right, very nice. Well done. And now we are almost there, matrix. Okay, in order to get the max length of QKT, we know that the maximum will occur when x is equal to 1/4. So we can now go and take that and sub it in. Okay, good. Well done, everybody. All right, what are we getting as an answer? I'm also just working it out to see what you guys get as well. Okay, I didn't get exactly 6. That's it. For me, I got the same answer as you, 24/7. Yes, which is 6,75. Okay, so 24/7. So you can write it as, sorry, 27/4, sorry. 27/4. Or if you wanted to, you could write it as 6,75 units, like so. Okay, the maximum length of QT. So the maximum will occur when QT is equal to 1/4. So the idea is this, all right? This is the part that's hard to imagine, but QT is not a fixed line. It can move. So in other words, what it's going to do, and I'm just going to draw something over it. Let's draw it in a nice bright color. So here you've got QT. All right. So QT can move. If I move QT over to the right-hand side, what's going to happen to QT? it's going to become shorter and shorter, isn't it? So in other words, if I move it over here, oh, sorry, that's not what I wanted. What's it done? Ach, here, man. Okay, I'm not going to do that. Okay, so if I was to move QT, let's do it this way. Let's go old school. If I was to move QT over to this side, it would become shorter and shorter and shorter and shorter and shorter and shorter. Does that make sense to you? As it moves towards this point of intersection, QT would start to become shorter. If I move QT over to this side, perhaps over here it's longer and then longer still and then longer still. So I want to find out when the distance between this bit over here and this bit down at the bottom, when is that at a maximum? When is it the longest it can possibly be? Does that make sense to you? That's what we're actually trying to calculate. All right, so the line QKT can move. It can move to the left or it can move to the right. When is it going to be the longest? Does that make sense to everybody? All right, so the place where it's going to be the longest is when x is equal to a quarter. So that's somewhere around about here or here. I'm not 100% sure. Then QKT will be at its longest, its maximum length. Are we all right with that, Matrix? In this particular question in Konizer, they would not ask you for a minimum length because it would be over there, all right, at that point over there, so it would be 0. Okay, but what they can ask you to do is they can ask you to minimize something like, okay, not in a functions question, but they could ask you to minimize area or minimize cost or to, so there are applications where they could ask you to minimize, but in this case, it wouldn't make any sense. All right. Okay, so that was out of 6. So we would obviously have to get a mark on the derivative. We always get a mark for making the derivative equal to 0. Perhaps a mark on this line over here where we've got an accurate simplification of x to the power of whatever it is equal to our base. It's out of 6, isn't it? So there would have to be a mark on that, a mark on subbing it in, and then a mark on our answers. That's 6 ticks. 1, 2, 3, 4, 5, 6. Yes, it is. Okay, all right. Well, if everybody's happy with that, we can move on and we can go and have a look at the next question. So we might come back to that. It's a similar idea, but what I wanted to do was go through this question with you guys. Okay, so in question 5, we are given 2 graphs, f of x equals minus 2x squared plus 4x plus 16, and g of x is equal to 2x plus 4. If we have a look at the graph, we can see that A and B are the x-intercepts. It tells us this over here, and that C is the turning point. Now, what's quite nice about these questions is that the beginning ones are really quite easy, and then after that, it gets a little bit more difficult. All right, so when they ask us to calculate the coordinates of A and B, that's super simple. They want the coordinates of the x-intercepts. So our rule is to make how would we work out the coordinates of A and B? We would need to make y equal to 0. Okay, so I'm going to let you guys do that bit, and then we're going to talk together about how we're going to do 5.2, because I just want to point out to you all the different ways that you can do that. Okay, so you guys do 5.1, and then you're going to DM Yolanda and I your answers.
All the best, guys. Try it. Act as if you are writing that paper tomorrow.
Yes.
You'll find something like this.
Okay, see how we've got answers already. So how, if you want to, you can go on with the other questions if you feel like it. I will go through all of these so that you can mark your work. But if you want to go on, see how, don't let me stop you. Okay. Thank you, Chad and Chloe. Good, Iola, well done. Okay, so they were very nice. They made this one out of 3 marks. And Lafatso, you're the first person that sent coordinates. Well done. Mbalentle, that's correct. Well done. You've done the correct thing for 5.2. That's nice. Lovely. Good. Well done, Nkanaza. Good, Nkanaza. That's correct. So I'm just going to catch up to you guys. So all of you would have made f of x equal to 0. We would have divided through by -2. And we would have factorized. So we would have got this, and we would have said x is 4, or x is equal to -2. So be as traditional as possible. Answer the questions they asked us. They want the coordinates of A and B. Give them what they want. So the coordinates at A would be -2 and 0. The coordinates at B would be 4 and 0. Okay, so you always hear me saying this. Remember, in the line with your factors, do not leave off the equals 0. Okay, they're very fussy about that. If there's an accuracy mark on that line, they will not give you that mark. Okay, so accuracy for our factors, and then they may penalize us if we didn't write them as coordinates. So let's write our answers as coordinates. Cool beans. Okay, so a lot of you are sending through the answer for 5.2. That's very nice. Well done. What I just wanted to discuss with you very quickly, and all the answers I've received so far are perfectly correct, is just the number of different ways in which we can work out the coordinates at C. Okay, so perhaps the most obvious method would be to use x equals -b over 2a. That calculates the x coordinate at the turning point. And since they've given us the graph in standard form, we can come along and we can sub in -4 2 into -2, and that's why x would be equal to 1. Right, so that would be one way of doing it. Yes, good, Iola. Love the suggestion. So Iola said the other way that we can do this is to use the derivative. Beautiful. So we're going to use the derivative. So we're going to take the derivative of -2x squared plus 4x plus 16. This would give us -4x. Remember to take the 1 away from the exponent, plus 4. If you're using the derivative, remember you've got to show that it's equal to 0. Okay, otherwise they're going to penalize you. So taking that 4x over, we would also get x is equal to 1. So that would be another way of doing it. Thank you for that, Iola. Quite right. And then there is a third way, Matrix, that you can find the x coordinate at the turning point. And can anybody tell me what that is? What is the third method? There's actually 4, but I mean the fourth one you're going to want to stay away from. What is the third way that we could find the x coordinate at the turning point? So either it was using x equals negative b over 2a, or you could use the derivative. There's actually a third way we can do this. Can anybody tell me? Correct answers, Wanaka. Lovely. The third way is to use, that's it, Nkaniza. Good. The midpoint. Beautiful. Okay, because your x coordinate at C is the midpoint of your x-intercept. So you can say x equals. Remember, at A, our x coordinate was -2. At B, it was 4. And then we can divide our answer by 2. So that would give us 2 over 2. So x would be equal to 1. So either of those three methods. Stay away from completing the square. It's nasty. We don't want to do that unless asked to do so, which would never be at matric level. But any one of those methods. In order to work out the 18, you guys would obviously have to go and sub in. So here we would sub in f of 1 into -2 times 1 squared. Is it plus 4x plus 16? So plus 4 times 1 plus 16, and then we get 18. So quite right, the coordinates at C, 1 and 18. Beautiful, well done. Okay, now question 5.3. The range of f. What is the range of f? What is the range of f? That's it. Okay, so in Nkaniza, you've sent me an answer. I'm just looking at 5.3. I don't know if it's just because of a typo, but you've left something off. Yes, Chad, quite right. Okay, so y, we've just got to be careful here. That's it, Lesedi. Beautiful. So y is smaller than or equal to 18. Okay, it's got to be equal to in this case because 18 is its maximum. Okay, so it is equal to 18 when x is 1, so we are including the 18. Of course, the other way that we could write this question if we wanted to is y is an element from negative infinity with a round bracket. Oh, sorry, please can we just mute? Thank you so much. Up to 18, like so. That's fine, Nkaniza, no worries. No worries, no worries, no worries. I know it's difficult. Okay, so two ways in which we can write down the range. All right, now 5.4, I see Nkaniza's already sent you through something on that, but let's go and have a look at 5.4. So in this question, they have told us the graph of h of x equals f of x plus p plus q, and it has a minimum value of 15 at x equals 2. Determine the values of p and q. So what's going on here? Who can describe what the question is giving us? What's the question saying? What does it mean? Does anybody know what this means? Yes. Okay, in Nkaniza, that's a very, very nice interpretation of the question. Quite right. So what you've got is the current graph, which has its turning point at 1 and 18. And then this new graph, h of x, has been created using a transformation. right? When they write f of x plus p plus q, what kind of transformation are they suggesting has taken place? Is it a reflection or is it a translation? What are they implying by the question? Absolutely, Lisedi. So they're implying it's a translation because they are changing x, they're adding onto x. So adding or subtracting from x can either move the graph to the left or to the right. And then the plus q at the end implies that we're either moving the graph up or down, right? So it has a maximum of 15 at x equals 1. Well, the current graph has a maximum of 18 at x equals 1. So in other words, this new maximum, okay, it's somewhere over here to the right-hand side. So let's call it C prime, and its coordinates are 2 and 15. So this graph is also downward facing. There's its maximum. I'm just kind of sketching it over there. This is the graph of H. So in other words, matrix, the turning point has been moved from 1 and 18. It has been moved over to the right and it has been moved down. Okay, so it's been translated to the right and it has been moved down. So what are the values of P and Q? What are the values of P and Q? Can anybody tell me? What are the values of P and Q? Q's the easy one. Okay. So see how are you on the right track here? So Lisedi Q is not 15, it's by how much it's changed. So what they're asking you, they're giving you the start, they're giving you the end, and they're asking you for the change. That's it. Good, Lisejo. All right, so P is 1 and Q is -3. Okay, the graph has been shifted over to the right-hand side and it has been shifted down by 3. Right, is everybody happy with that? Okay, cool beans. All right, question 5.5. Now they want us to determine the equation of G to the -1 in the inverse of G in the form y equals. So here's our equation of G up here. They want us to find the inverse. Are you guys okay to do that one on your own? I'm going to let you find the inverse on your own. Okay. So again, you can DM either Yolanda or myself. Good, Lesedi, quite right. So Lesedi sent me an answer. Good, Lesedi. Yes, Chloe, that's correct as well. Okay, Lesejo, that's fine. Yes, and Koniza. Good. Well done. All right, so in 5.5, I'm squeezing it in over here. We have got g of x equals 2x plus 4. So switching x and y around, we'd have x equals 2y plus 4. So that would give us x minus 4 is equal to 2y. So y would be equal to x minus 4 over 2. Or if you want to, you can then write that as y equals 1/2 x minus 2. So either or, it doesn't matter. Okay, good. Well done. That's perfect. The answers that came through were all 100%. Okay, now question 5.6. For which value or values of x will g to the minus 1x times g of x be equal to 0? So what is this question about? What are they asking us here? What does it mean? What does this mean for us? Can anyone tell me? Okay, so this is one of those sorts of questions that often throws us. We just kind of see something like this and think, oh, I'll never understand what that means and move on. All right. When we do begin to understand what they're asking us, we realize it's actually not that bad. Okay. So here, what they are talking about, this g to the minus 1 of x. Okay, so it's not gradient, it's great. When they want gradient, then they're going to use derivative, right? So if they wrote g prime x, then that would be gradient. Okay, but here, g to the minus 1x, this notation that they've given us on the left-hand side is for the input. Excuse me, sorry, I'm sneezing all in your ears. Okay. It means the product of the y values. Yes, equals 0, quite right, Nkoniza. So this is the y on the inverse. This is the y on the graph of g. So you are multiplying two y values together and you are getting 0. Yep. So Chloe, I think you're overthinking the question a little bit. It's only out of 2. So now if you think about this, guys, how is it possible for something to be equal to 0? Either, so for this to be true, either this must be equal to 0 or this must be equal to 0. That's the only way that this can happen. Okay, so where is y equal to 0? Y is equal to 0 at the x-intercept. So it will be the x-intercept of the inverse and the x-intercept of the graph of g of x. Okay, so the x-intercept of the graph of g of x, because this is the graph g of x equals 2x plus 4, for its x-intercept, 2x plus 4, your x-intercept would be at -2, isn't it? Because it would be -2x equals 4, so x would be equal to -2. So that would be one of our answers. So either where x is equal to -2, because that's where g of x is equal to 0, and for this graph, which is the graph of half x, I think it's -2, yes it is, it's going to be where this y was equal to 0. All right, so let's take the 2 over to the other side, and then we can cross multiply. So this would leave us with 4 would be at 4. So either where x is equal to -2 or where x was equal to 4. Okay, does that make sense to everybody? So the only way that this can happen is at the x-intercepts, because that is where y is 0. Okay, so the y on the one times the y on the other, if it's equal to 0, it has to be at the x-intercepts. Okay, so where y is 0 in Kanaiza rather than where x is 0. Okay. Yes, Lucidi.
Hi, ma'am.
Hi, Lucidi.
Ma'am, may you please explain that again?
Okay, all right. So, Lucidi, you know when you are solving a quadratic equation and you've ended up factorizing it. So let's say you've got x plus 3 times x minus 2 equals 0. Right? So the only way that you can have two things multiplied together, if you want to solve the values of x where this happens, either it's going to be where x plus 3 equals 0 or where x minus 2 equals 0. So for the product of two things to be 0, either the one is 0 or the other one is 0. All right, so the one value of x making the product equal to 0 would be when x equals -3. The other product would be, the other value of x for which the product is 0 would be 2. It's exactly the same idea. Okay, so here what they are doing is they are saying when I multiply 2x plus 4 with half x minus 2, I want to get 0 as an answer. Okay, because that's what the product of these two is. Okay, so either 2x plus 4 equals 0, in which case x will be equal to -2, or half x minus 2 is equal to 0, in which case x was equal to 4. Okay, do you understand? Maybe it's a little bit easier when I put it like that. Okay, so here was g of x, and here was g. Okay, so you're timesing them together. Where will it be equal to 0? Okay. Cool. All right, and then the very last question, I'm worried that we're sort of running out of time now. Let's try and squeeze that in. So they've told us if p of x equals f of x plus k, determine the values of k for which p and g will not intersect. So first of all, p of x, let's just make some space here. I'm just going to rub this off. So if p of x, sorry, because we did start a couple of minutes late with me being on load shedding. Okay, so p of x equals f of x plus k. All right, so if you recall, f of x is minus 2x squared plus 4x plus 16. So this is minus 2x squared plus 4x plus 16 plus k. For which values of k will P of x and G of x not intersect? So when they say not intersect, it's sort of in Konizer, sort of, yes. They want us to do an algebraic solution, and they want us to do nature of roots. When two graphs or two lines do not intersect one another, we would say that the roots are non-real. So that's what they mean when they say do not intersect. Okay, they're talking about non-real roots, in which case delta will be negative. So in other words, b squared minus 4ac has to be smaller than 0. So what we would do is we would take p of x, which is minus 2x squared plus 4x plus 16 plus k, and we would let it equal g of x. Remember they said here in the question, determine the values of k for which p and g will not intersect. Remember, g of x is 2x plus 4. So we're going to make these two equal to each other. All right, now we're going to get it into standard form. So this gives us minus 2x squared plus 2x plus 12 plus k equals 0. And now that it's in standard form, we can say that the value of a, the coefficient of the x squared term, is negative 2. The value of b, the coefficient of the x term, is positive 2. And c is everything else. So c is 12 plus k. Now we want to sub this into delta. Okay, so we've got b squared minus 4ac for non-real roots. For non-real roots, delta is smaller than 0. So we're going to sub it into that. So b squared is going to be 2 squared minus 4. A is equal to negative 2. And c is equal to 12 plus k, smaller than 0. So 2 squared is 4. It's easier for us to multiply these two numbers together. So negative 4 times negative 2 is positive 8. And now we've got 12 plus k smaller than 0. So this gives us 4 plus 8 times 12 is going to give us 96 plus 8k is smaller than 0. So that means that 8k will be smaller than, we're going to take the 4 plus 96, which is 100, over to the other side. So it will be negative 100. And now we're going to divide both sides by 8. So k will be smaller than negative 25 over, divide by 4, divide by 4. So that would be 2.